Thank you, Darren. Thank you, GeoDirectory, for inviting me here. Uh, as just a second. Yeah. Sorry. Hi. Yeah. So as Dara introduced, I work as a part of IBSO, which is a research body that was developed or founded by SEAI, and SEAI is particularly Research Island Center for Energy and Climate. So we are funded currently by the MaREI and the SEI Predict project. The main goal for our research body is to provide better understanding of the energy performance of the building sector that we have currently in Ireland. So we want to develop robust and transparent building stock energy consumption models to check which building types can be retrofitted and which can meet the island's climate action plan for 2030. So before we build those models and we develop archetypes of buildings, one of the key challenges that we faced globally as well as in Ireland is the availability of key data. So there is a lack of observed data, and there are data that has been collected by various agencies and institutions, but they haven't been done in a proper way or in an adjusted way. So there is a lack of documented transparency among the energy performance models, and there is a lack of prioritization to accumulate and assimilate those data. So our job comes here is to form a complete and a rich data set that can barometer the island's progress towards its national retrofit targets. Uh, in the climate action plan, it is there that by 2030 we need to be retrofitting 1 in 4 residential buildings with a energy rating of B2 and higher, and at least installation of 1 in 5 homes for heat pumps. Now, to meet these cap, we need to have and actually visualize the progress of data. So how many buildings by building type and by building location, how much are being updated to that particular category of energy rating. And we provide that information in a very clean and visually appealing way, I would say. So our core principles come from the fundamentals of the climate action plan, which are to lower greenhouse emissions, to reduce dependence on imported fossil fuels, to reduce the energy costs, and ultimately to improve the quality of life. So our research outputs, what we have done until now, is we have developed stock models for residential buildings, which has undergone peer-to-peer review, and we have published them in open access journals for people to understand as well as and to verify. We have also developed filtering methods so that we can, sorry, yeah. We have also developed filtering methods to classify each of the residential sectors, which I'll show in a little while, of types of archetypes that have been there and how we can retrofit each of those specific types of buildings into the particular targets of energy ratings. Then there is heat loss methodology. So there are the current heat loss coefficients that are being presumed on very pessimistic data. And we want to evaluate that, and we want to rectify those heat loss coefficients of individual buildings so that we have a more realistic update on what is the heat loss of individual buildings and how we can retrofit those targets as well. We have developed a visual platform, which I'll show in a little while as well, that shows and actually barometers those progress over time and over. So we have a quarterly update method. So we update our data based on our evaluation every quarter, and we give that to open access to everyone. And we have developed a built environment research community with other universities such as University of Cork and Galway, as well as UCC, to have cross relations and to have cross research among various other faculties. So the things that we have done as of now. So for residential buildings, there are residential building archetypes that we have prepared. So if you see, there are over 52 different archetypes, but some of the dominant ones are the 20 predominant ones. And we have classified them best based on their type of construction. So there is a construction period they have, the type of heating and insulation that was installed in them, and how they perform in terms of their energy consumptions over time. So majorly, if you see, there are the semi-detached houses, the detached houses, sorry, uh, then the mid-terraced houses, the end-of-terraced houses, and apartments. So they mostly cover those 20 archetypes, mostly cover 85% of the residential building stock currently that is there in Ireland. The list continues on to similar types of apartments, but then we have also categorized apartments into top floor, mid floor, and ground floor, because the patterns of consumption of energy we saw was different. And we started from a bottom-up approach, so we didn't have those classifications at the beginning. We had the data, and we cleaned that data, and we ran it through clustering models to check what sort of patterns emerge, and these were the most predominant patterns that came out. So based on that, we classified a dwelling categorization. Now this is available in our IBSO websites. We have the dwelling types that has been evolved over time. So around 90,000 buildings were there in 2023 Q4, and by 2024 it has been increased by almost 50,000 buildings. For the retrofit status, we also track that how many buildings have been covered over time to B2 and above energy ratings. So again, as you can see, almost 683,000 buildings still need retrofitting of the total housing residential buildings that are there currently. There is a small video that I would like to play on with our website, and highly urge people to go and have a look at it. IBSO, we provide the retrofit data, the BR status over time, how many buildings in the residential sector are there in each of the categories, and what requires targeting for retrofit statuses. So as you can see, we have the retrofit statuses over time. We also have demarcated it through urban and rural areas based on the map. There is a map as well to check county-wise as well as each location, small area code-wise. So as per the proportion of buildings by typology, so as I said before, there was semi-detached, detached apartment and terraced houses, and we have that evolution of time. So we try to track the data quarterly to provide a better understanding. And this is the map that we have. So in terms of properties by county, and how are their energy consumption models change over time based on the dwelling type that we have created. So we also have the main fuel data, as in what is the main fuel consumption for heating of those buildings in time. So we can have a look at small area codes as well. So it's quite detailed and quite nuanced in terms of what sort of targets that you're looking for. Now, the next step is we did this entire research for the residential buildings, and thanks to GeoDirectory, where their help contributes to us, is the commercial buildings. Now, we want to extend our research to commercial buildings. Now, this is one of the reports in IEA 2020, the International Energy Agency, which said that the total greenhouse gas emissions of the residential buildings is around 20 to 25%. If you take in the embodied carbon as well, like the carbon emissions that happens during the construction of the buildings. But similarly, if you see for the commercial buildings, it's around 8 to 10%, which increases to about 15% with the embodied carbon. So we wanted to target that aspect as well, because Ireland has a lot of commercial buildings in itself, and it requires a retrofitting targets. It requires to meet those retrofitting targets in the coming future. So what are the commercial building stock categorization? So just like we did for the residential building archetypes, we need some sort of archetypes for commercial buildings as well. But one of the key factors or key differences between residential buildings is residential buildings are typically homes and apartments, but commercial buildings have a lot of variety of buildings because of their business classification, what type of building they are, what are they performing, how much energy consumption do they have to do. And also a typical commercial apartment can have more than one business activity going on at the same time. So the energy characteristics vastly differ from residential as well as from commercial buildings. So so this is where GeoDirectory comes in. The GeoDirectory has the business classification, that is the NSE classifications that they use, and also they have the small area codes and the census data in them. So we try to annotate that data with the SEAI dataset, that is the BR dataset that we get for the energy consumption for both the residential as well as the commercial building dataset. We have that data, but we try to find the classification for commercial buildings based on the GeoDirectory dataset. So just to show how GeoDirectory helps us, so GeoDirectory has the geographic location, the business classification, and the building characteristics like floor area and vacancy statuses. And from the SEI dataset or the BER dataset, we have the BR ratings, the energy consumption, as well as the building environment or the heating and the fuel status of those buildings. So our job is to link those two data sets and try to create a holistic data sets for commercial buildings and to see what sort of archetypes or classifications we can do on the commercial buildings in order to see how they perform in their energy consumption. So, yeah. So once we do that, once we get those, so currently we are at that stage where we are trying to find that sort of archetypes for classification of commercial buildings. Once we do that, it will help us develop your real-time energy stock consumptions models like we did for the residential buildings. Also, it helps us improve the EPC data set. So once we have those energy consumption models, we can predict how they are going to be consumed in the future and how they can be retrofitted. And that closes the gap towards the poor data that we started with. So our job is to expand our data sets within the energy consumption, but also integrate with other utilities like ESP, like the gas networks, like energy and water CRU departments have. So in order to create those different data sets, we need to have the building archetypes that we are working on currently. And our goal is to support industry in terms of designing and modeling better models for retrofit targets that we want to meet there. As Dara pointed out at the beginning, GeoDirectory has very good insights in the recent GeoDirectory commercial buildings report that almost 30,000 of 210,000 buildings are vacant commercial properties, which is almost around 14.5% of commercial properties in Ireland are vacant. And specifically, if in Dublin, you look at, as Dara pointed out, Dublin 2, which is the heart of the commercial activities in Ireland, has vacancy of a rate of 18%, which is higher, 4.2% higher than the national vacancy rate. And once we do that data analysis and modeling for energy consumption in commercial buildings, one of the key things that we can look at or we can think of researching further are there any energy implications for Ireland's commercial vacant commercial properties? So is there a measurable correlation between the vacant buildings and types of energy consumption that those buildings have across the different regions of Ireland? Can retrofitting help them? Whether we can bring back useful buildings back to use if we can retrofit those targets? And if so, what type of commercial buildings should be prioritized to retrofit based on our archetypes and based on the classifications that we do? Finally, so that is our whole goal of this particular project, and we want to promote more energy efficient upgrades, reduce resource wastage, minimize our ecological footprint, and leverage data and drive innovation. That's it. I think I'm on time right now. So thank you. Yeah.